ConnectCAD creates schematic layers, rack, both 2D and 3D, layouts, error checking, reporting, and an easy way to make changes and update the design. An overview of the workflow. We work with the conceptual drawings, not worried about make and model at this point, where we just want to make sure all the components are in the design. From there, we take that information, we develop a schematic layer where we place the devices, add sockets as needed to those devices, adapters, and any of the connector panels, jack field, terminal panels, and other devices. From there, we work on both 2D and 3D elevations, both room and rack positions, and then after everything is in the design, we verify with error checking, making sure that all connections and connector types are not mismatched. We then are able to output reports, send those reports to the field, and get the as-built information and update the designs from that information. And finally, going into a 3D layout, we can create really nice presentations in Vectorworks. We start with template files. The file will have a group of resources that you want to start with, so starting with a template document, either metric or imperial. In that you'll find 3 design layers: schematic, rack elevation, and rack 3D layout. There are also 3 sheet layers to match up to those. The 3 toolsets you'll find in the ConnectCAD workspace are schematics, where you'll find the connection tools, the device and device builder tools, adding the sockets, adapters, and panels as needed. The next is the layout tools, where you'll find that we create layout rooms, equipment items, rack frames for modular devices, and both 2D and 3D racks. Finally, we have the cable route tools, where we develop the cable network, draw points, edit the cabling, add spare cable, and then query the cable network. In settings, the first is the general settings, where we have the device unit, both power and weight, circuit label offset based on the grid spacing, some default circuit graphics, panel settings, both the label and the size for jack fields and terminal, some numbering standards, signal, connector, cable types, and cable groups can all be defined and easily added and updated. Next, our units and spacing is based on our grid spacing. You'll see I'm working in metric, 4 millimeters for my grid spacing, and that will give me the spacing when I create devices in between the sockets. Also, how the labels are arranged away from the sockets based on their grid spacing as well. New this year, we've revamped the organization for classing, and you'll see it's much easier to find with a prefix of CC, and all the different styles are all broken out. Let's start off with making some devices. The first, we use the device tool. There's a basic device and an insert device, and a pick up and apply mode. Let's start off with the first, a new device. The basic device, let's give it a name. We'll call it speaker, and give it a unique number, speaker 1. In a description, a near field monitor. We'll put in a make and model. At this point we can save the symbol, give it a height, a weight. We'll keep this one simple. We need a way to attach to this device. So we'll start off with the socket tool. There's a socket loop as well. We'll give it a name. We can use a single or a linear array, whether it's on the left-hand side. We now have a way to connect to this device. Very easy to update. The new socket edit tool, we can directly edit sockets without going into the device edit mode. Give this a signal type. It narrows down the list of necessary connector choices. From there, we can also use that device for pre-made symbols, both in the user library or in the current file, and using a single or a linear array mode. We can insert those devices. It will automatically number based on the number that was saved with the device. Very easy to renumber at any time, devices or circuits. In this instance, we'll start with 11. New last year was a pickup mode. We can take attributes from a device. In this instance, we'll modify this device. We'll just change a little bit of graphics, move one of the sockets, and give that a different fill. Once we have anything changed on a device, we can use the pickup tool in the device, select, and drop onto any of the existing devices. Next, we're going to go into the device builder. In this instance, we're looking for a mixer. It's in our database. We'll give it a name. And if we want to add sockets, we can do it after or upon creation. In this instance, we'll give it a power inlet. We'll just go with a 3-pin female XLR. Easily edit any of those sockets or that device and save as a symbol or to our database. We can save to the current file, which will store a symbol in our resource manager. These can be shared to common library files. Or we can save to our database. And this will populate in our user folder when using the device builder. We also can apply custom records to any device. In this instance, I did one for network. And if I go into the device edit mode and use the text tool within that symbol definition, if we place a text field within, and we'll label that IP address, and it gives us linked text where we can link to any of the parameters of the device, or in this case, the IP address from that custom record. We can find that in the Data tab when we select the device. We can also edit custom graphics and change any of the attributes of the device. Let's move on to connections. We've put two example audio mixers in. We have the connection tool, reroute circuits, reshape, and a hop over tool. The first, a single connect or a multi-connect, and a couple of line types, polyline, rounded, chamfer, and an arrow. Let's start off with a rounded. We click on a socket, choose our path, and then make the connection. We can then, if it doesn't automatically apply a signal, then this choice it had a mic line to a line, so it didn't automatically choose. I choose a line style, and then I can choose the line type after or before. Next, let's go to a multi-mode. We'll click and set the path. And you'll see as we scroll up and down between available socket groups, the available number of connections. Let's select these lines, give them a signal type, and then we'll number the cables, just the selected circuits. We can choose the number display to have it at the source, destination, or both. And the cable type will give us the diameter of the cable and give us our volume and our cable routes. If we double click on any of these lines or select the reshape tool, we can use the control handles to move these points around, add points as necessary, and then we can use the reroute circuits tool to reroute other circuits to that path. We can use that tool as well to align the custom circuit graphics. And one other cool trick, we can use it to fan out the lines. And speaking of the custom circuit graphics, in the ConnectCAD settings, for both an arrow style and a line style, we can insert any field into the connection circuit and give that a bubble style. In this instance, we'll give it the cable type or the signal type. And then when we switch to line, and then we can use that reroute circuit tool. Now if we have two devices and we want to just see the source and the destination and an arrow, including which layer they're on, We can choose before or after. To use just an arrow, and one of the nice features of this is that if we're zoomed in to the source, we can navigate to other end of circuit. When exporting to PDFs, this will also work within a PDF. Next, moving on to jack fields. We have optical, data, audio, and video jacks. We'll start with a group, a panel number, a port number. We can insert these into circuits. We also have the ability to combine the panel or to split it up into individual. This allows us to be able to use the multi-connection tool. Or we can place on individual circuits anywhere in the run. A great new addition this year, the adapters. Adapters can be placed symbol-based. It's a good collection in the content library, or you can build your own. And let's put one onto this mixer. You can put these directly onto a device, or you can insert them into a circuit. Easily moved after the fact. And we'll connect those up to a few of the RCAs on the other side. And these will be in a separate group for reporting. Make sure that all the adapters are allocated in the cost control. Let's add a little bit to this design. We'll start off. We have some rooms and a cable network. Let's add another room. We'll go into the layout tool set, grab the layout room, and we'll call this IT closet. Let's place a 2D equipment rack. We'll call this IT rack. And we'll match up a 3D version and link that in the object info palette to the IT rack 2D. We'll slide that back a little bit. The next thing we need to attach this to the cable network so devices that are in one rack know the cable path between. We can start off. Let's start off by taking the doors off the 3D rack. We'll also show the power and weight of the rack. Now going to the cable route tools, we'll connect that route from that rack. We have multiple heights that we can run this cable path. We've predefined these. And I can hit a modifier key to bring those up mid-path, And we'll jump up from the 0 level just over the door height, and then we'll draw this across the wall, through the wall, make a turn, and then stay at the same height and connect to the rest of the cable network. If I select that route, I can class that. In this instance, I made the line a blue and a little bit heavier line weight. Next, let's add one monitor. We'll show you we have the SSD drives, 2 media servers, some distros, some floor monitors on some stands. After we have these devices, we use this Create Equipment by going into the 3D view. We run a command that brings these devices in from the schematic layer. Once I bring these racks in and place the gear into the racks, I can use a new feature that adds predefined locations. We'll put the devices directly into these rooms and into racks, right down to the rack unit number. In this instance, I'm going to get any new equipment, run this command, and you'll see there was a few SSD drives that didn't make it in from the last time I ran that command. Well, let's go back to the drawing, the schematic layer, and we'll add a few items and bring those in. I'm going to start off by bringing in the 4th monitor. I'm going to leave that marked as floor monitor 3 to cause an error later on when we check. So I'm not going to relabel that. I'm also going to use one more input. We'll use an external link and bring an ISP provider into the network switch. The signal will be a LAN. Our J45 connector was chosen, and we'll call this ISP. Should have been a IO, but we'll just do that as an input. Connect that to the network switch. We'll add an adapter and feed that last monitor. We'll select an SFP to HDMI. And we'll put that on output 8. We'll connect to the HDMI of that last monitor. I'm going to add a connector panel. In this instance, it's going to be HDMI. It's going to be an input. I'll give it a panel name. We'll put that data racks. We'll do 4, so we'll use the linear array. We'll engrave on the ports HDMI. We'll start with number 1. And the connector, of course, will be an HDMI. We'll add those. And because it has a prefix of CTP, it's going to play a nice trick when we bring that panel in to get the connectors. Now we want to check the drawing. First we'll number the cables, make sure everything's numbered, and let's check for errors. We'll check the drawing. We'll start with just sockets. Now there might be problems that I want to correct. There might be things I'm not worried about. In this instance, the fiber distro has fiber 1 and fiber 1 on both sides. It's not a problem. There's a socket misname on those two adapters. We'll clear the markup. And let's run that one more time with devices, circuits, and signals added. You'll see it marked up some of the signal types. We should put an adapter in between some of these, as well as the floor monitor has two number 3s, so we would want to correct that one and just identify as one as number 4. So easy to find our corrections. We'll clear the markup. Now let's add a few devices. I'm going to copy drag one of these. We'll give it number, we'll call it a spare. Now we can predefine the location. If we give it the room of IT closet, it'll place it within that room. If we want it in the rack or a rack unit number specifically, we can add that. So now we're going to run that command. We've added a few items. Let's go to our overhead view and run that create equipment. We'll bring in just from the schematic, and we'll see it brings in the new items. One wasn't assigned. We'll bring that down and place that closer to the rack. We have those SSDs. We'll place those in the IT closet. Let's put them in a rack chassis over an AV room. We'll put a rack frame. We can configure that where we want the power supplies, give it a make and model if we want, but we'll just keep this simple. We'll drop these drives into those modular units. We'll keep a space in between each of those. They now know they're in that room, in that rack, in which slot they're in. Now that CTP underscore that I mentioned before, that's going to play a nice trick when we put this into the IT closet. We'll make that unit just a little larger. We'll give it 3 spaces. We'll drop that Apple TV into the rack as well. Give that 3 rack spaces. And then because it knew those connectors from the connector panel, we can then arrange those connectors within that panel. I'll just drag them down quickly. And a little bit of rearranging. Close enough. We'll exit that. Now it's time to generate some reports. Let's start off From the schematic layer, let's go to documentation and create a circuit report. There's some nice new predefined reports. Let's start off and we'll show you how we can edit directly from the list. Let's go over, we'll find net 1001. We could go in and call this N2002. You'll see it updates the drawing. We can also select the drawing and update from there, and then update the worksheet. We can copy and paste. Now we can send this to the field by breaking the connection as a database. In ConnectCAD, let's convert this report to a list. It no longer has its database functionality within the drawing, but we can export that to the field. It'll open up directly in Excel. And then we can edit from there. In this instance, let's go and we'll do a fill series. Save that drawing, that Excel sheet. We can close that. And then back into Vectorworks, we can import that worksheet. You'll see our numbers have updated, and then we can run the command compare cable list and drawing. That will show me any of the mismatched numbers and mark the drawing up accordingly. Let's analyze some of the cable routes. If we select these cables, you'll see their cable type has been selected. And in our settings, under cable types, you'll see the different types of cables we have available, including their outside diameter. With that applied, I can use the Edit Cabling tool and select any portion of the cable network, and it'll tell me what's in there. At this point, if I would like to add spare cabling, and I highlight that route, I can then add the necessary spare cable. It will then put those on a separate layer of spare cabling. I can then use these anywhere I want by assigning those to the schematic layer and connecting those to any available sockets. Now let's calculate some of these cable routes. We'll see I need 228 square millimeters. Cable count is 5. Now from this information I can determine a riser diagram. We're going to go from this in documentation Analyze the cable routes. Calculate the cable lengths, including any of the service loops. And then create and then a new feature this year is to create riser sheets. I'm going to put this one on a sheet layer from a right isometric and auto annotations. These are applied as data tags, and I can edit that tag data and select from a list of conduit or raceways. This list can be modified, and there is a record and this list can be modified under the cable containers record by editing this pop-up. We can add any instances we'd like. And last, let's go into documentation and create a cabling sheet. The source is going to be from the 3D overhead. Sheet layer. We'll put that onto the cable sheet. And we have a slider to determine where our home runs start and where the arcs take over. We're going to kind of lead this more towards having more arcs than home runs. And again, this is on annotations. If I double click this, right click on that. And then if we select and right click, edit annotations, we can then move these tags around. Adjust the leader lines. And you'll see where we have a balance between the home runs and the arcs. So one of the great ways to work in ConnectCAD is to use the multi-view. In this instance, I can select it and have different views set up in between racks, schematics, and I can see devices instantly placed from the schematic directly into the 3D layouts and the rack elevations. And finally, just an overview on some of the new additions in 2023. We went over a little on the adapters. Adapters work like devices and will be allocated in reports separately, so make sure that all those expensive adapters get accounted for. We had cable sheets where we are able to drag a slider when we produce these sheets to balance the home runs to the arc line style, and these are all symbol based, so easily using these data tags to produce these layouts automatically, as well as the riser diagrams, where we can set and choose conduit and cable raceway styles and annotate those easily. We also have some new predefined reports. The device report, parts report, and cable report have a new look and are much better suited for including adapters and other new objects. The classes, we revamped the classing last year, where we added the prefix of CC, very easy to use this as a filter, and much better organization for our classes. Location presetting, where in the object info palette we now have the ability from the schematic layer to preset these locations in the 3D layout in the rack elevations, where we select the room, the rack, and then we'll get a drop-down menu for which rack unit. And finally, smarter choice lists. When you pop up a signal, before you had the entire list of available connectors, and now these are linked to the signal types where you see shorter lists, much smarter, and you can choose which ones you would like to populate in that list as well. We'll leave you with places where you can go and learn more. Vectorworks University is the best choice, where we have all things Vectorworks, courses, and if you type in ConnectCAD, you'll find the specifics we were talking about here today, as well as some sample documents. Certifications, once you learn this, you can take tests and get some documents proving your knowledge of Vectorworks. These are both for the core concepts as well as some new entertainment industry offerings. Our forums. A lot of great people out here all around the world, so day or night you can always find some topics with some feedback from other users. Great place to make suggestions and report on any issues you might be having. And finally, our help page, where you'll find all the topics we went over here today and more, taking you step by step through creating a ConnectCAD drawing. We'll open it up to some questions now. Thanks for joining us.